So yeah, last time we discussed what is electrolysis. Now can you tell me what is electrolysis?
Um, it's like when like a current is passed through an electrolyte and it breaks down.
Okay. And okay, can you tell me why solids they do not conduct electrolysis process?
Because the particles are in fixed positions and there are no free electrons. So,
Excellent. Right, right. And what are the electrodes made up of? The electrodes, the cathode and the anode.
um, um,
So they are made up of carbon, graphite, you can say. Okay, some of them are a copper also, platinum also, but generally we use graphite. Okay,
okay.
graphite, yeah. And can you tell me when the electrolysis process occurs, so the metal ion, it moves towards which side, cathode or anode?
Um, the cathode.
Yeah, it moves towards the cathode, and that means there is gain of electrons, and that we call it as reduction, right?
Yeah.
And what about the non-metal? Non-metal moves towards the anode.
The anode.
Excellent, and we say that oxidation has happened, and like reduction and oxidation. Are you able to write the ionic equation also? The half equations we call it as. Yes,
Um, yeah.
I told you about the half equation.
Yes.
Yes. So there were four steps in that. Remember, first you were supposed to write the symbol of the ion, then the symbol of the atom, and then you were supposed to write the you were supposed to balance the number of atoms, and then balance the charges. Do you remember that?
Yes.
Yeah, okay. So let's start with the electrolysis of the aqueous solution. Okay. Now, can you tell me what is aqueous solution?
Um, it's uh,
Okay, what is an aqueous solution?
it's like a liquid.
Okay, it's a liquid. So, what is the
Uh,
difference? We have four states. We have three basically states of matter, that is solids, liquids, gases. So, then what is the difference between an aqueous solution and liquid?
um, mm,
So, basically, aqueous solution is when you dissolve something in water, right?
okay.
Suppose I say, I use a word NaCl. What is this NaCl? Sodium chloride. If I say sodium chloride aqueous, that means when you do reactions also, right? So when AQ stands for aqueous solution, so NaCl aqueous means NaCl has been dissolved in water. Is it clear now?
Yes.
Yes. So now if you see, if we talk about water, can you tell me how many ions water has?
Um,
It's H positive and OH negative, right?
yeah.
Yes, this is very important. See, electrolysis of aqueous solution. The question can be asked like this. Suppose they give you a chemical like NaCl is there, okay, the electrolyte. So they can always say NaCl dissolved in water. So that means aqueous solution. Or NaCl in aqueous gives out this reaction or so. So you have to see, that means electrolysis of aqueous solution. Whenever there is a word water or there is a word aqueous, that means that electrolyte is being dissolved in water. Got it?
Yes.
So now what happens if I say a salt is there, salt you can say anything like NaCl is there, when you react with water, then the ions are formed, that are H positive ions, OH negative ions, and you can say ions from the salt, right? Ions from the salt like Na positive and Cl negative will be there, right?
Yes.
So now in this situation, so we have to see whenever you do electrolysis of aqueous solution, the products of the electrolyte, okay, they depend upon how reactive the element is, basically how much the element is reactive. Okay, so I'll explain you that also. Let me yeah. So now when we talk about the electrolysis of the aqueous solution, see, I'm going to draw one, this thing, this is a beaker, okay, and we have, here we have uh, two electrodes. This is our cathode, okay, and this is our anode, okay, and we have a power supply with this. Now here we have the aqueous solution. Let's take an example. Let's take the example of let's take copper sulfate, okay. Let's
Okay.
try that. Now if you see copper sulfate, that means if I say copper sulfate's aqueous solution, that means copper sulfate is dissolved in water, right? So now we have an aqueous solution of copper sulfate. Did you understand what do you mean by the aqueous word? So that
Yes.
means this is mixed dissolved in water. So if you see in the electrolyte, what will be there? There will be some copper ions, right?
Yes.
There will be some sulfate ions. There will be some H positive ions, and there will be some OH negative ions, right? OH negative. You understood?
Yes.
Yes, because it is dissolved in water. So if you see these many ions are there. Now see what happens is, if this is cathode, this is anode, and cathode, the electrons are there. Okay, so this is negative charge. So that means if negative charge is there, so all the positive will go this side, right?
Yes.
And here we have a positive charge, so negative will go this side. So if you see in positive, we have copper 2 positive and H positive. So now we have to see which one will go towards the electrode and which one will stay in the solution. One has to stay in the solution and one has to go towards the electrode.
Wait, I thought the positive ones went to the cathode.
No, cathode is dear negative electrode.
Okay.
Negative, okay. I'll write it here,
Okay.
negative electrode, and anode is always positive electrode. So in a negative electrode, what will go? The positive ions will go, right?
Yes.
Understood? Cathode
Yeah.
is the negative one. Okay, now, yeah, sometimes, there's always a confusion between this thing, but just remember this thing, that the cathode is the negative one, anode is the positive one. And if you see the electrons, they flow from the negative to the positive like this, right? And at cathode, reduction takes place. That also I'll write it for you. Reduction takes place here and oxidation takes place is here. What is reduction? That is gain of electrons, right? Here if you see, the electrons are being gained. Is it clear to you?
Yes.
See, don't get confused. You have to see that cathode is this one, and cathode is basically the negative electrode. Negative electron means there are more number of electrons. More number of electron means the reduction is being happening here. Whereas if you take anode is a positive electrode, and there is less number of this thing. Loss of electrons is there. Loss of electrons, more of positive charges, so oxidation takes place. Okay, so now if you see, let's talk about the negative electrode. So now what is happening at the negative electrode? What is the negative electrode? Can you tell me? That is cathode or anode?
The cathode.
Excellent. So now if you see at cathode, what happens is, see now we have two ions positive, like there are the copper ions also, right? And there are
Yeah.
H positive ions also. So when two ions are there, one has to remain in the solution and the other one has to go towards the cathode. So now which one will go towards cathode, we have to see that. Okay, so whenever the metal ions or H positive ions are there, they are present, then the metal ion stays at the solution if metal is more reactive than the hydrogen. Okay, that
Okay.
means whatever is more reactive out of these two, that has to stay. Now if you remember, we did reactivity series also, reactivity of metals. I think you have forgotten. Should I repeat it again?
No, it's fine.
You remember we did what was
Yes,
reactivity
I
series?
remember.
Okay, tell me what was reactivity series?
Um, how reactive all the metals are, like from most reactive to least reactive.
Excellent. So that means we had some list. I'll just write it here. So, like lithium also comes, calcium, magnesium, carbon, zinc, iron, H, copper. Now the more reactive is the topmost and the less reactive is bottom. Right. Now out of these, can you tell me which one is more reactive? Where are these present? One is here and
Um,
one is here. So out of these, which one is more reactive? Can you tell me please?
hydrogen.
Hydrogen is more reactive. So now who is going to stay? That means
Hydrogen.
hydrogen will stay in the solution and copper will go towards the cathode. So that means when copper will go, it will carry out reduction. You understood? Because
Yeah.
what was okay? I think you're getting confused. Are you getting confused? Because it should
No,
be clear
no,
to
it's
you. Okay, so now what happens? First thing at negative electrode, now you're clear. The more reactive one will stay at the the in the solution or the electrolyte, okay, and the other one will go towards the cathode. Now if there would have been magnesium and hydrogen, then magnesium would have stayed in the solution and hydrogen would have gone to the cathode,
okay.
right? You understood? And then you
Yes.
can write the half ionic equation for that also. What will be the half ionic equation? It will be this, right?
Yes.
You know how it has come up?
Yes.
Sure?
Yes, I'm sure.
Okay. Okay, so now this will happen. So now, okay, then now you are going to help me. Okay. We have a, now let's talk about the positive electrode. Whenever the electrolyte is in aqueous solution, you have to do this thing. Okay. Make sure when we talk about the aqueous solution. So now let's come to positive electrode. Now positive electrode means anode, and if you see, there are two ions or the two negative ions. One is OH negative and the other one is SO4 2 negative, right?
Yes.
Yes. Now what happens at like at positive electrode, they have a different story. Now let's talk about that. This is clear to you, so let's talk about this. Now if OH ions and halide ions are there, okay, if OH negative ions or which one are halide ions?
Um,
The halogens, you understood? Halide,
yes.
halogen,
Yeah.
okay. When they are present, then molecules of the chlorine, bromine and iodine will be formed. Okay, you
Okay.
understood? If
Yes.
this is present or this is present out of these, then these will be formed. Okay, if no halide ion is present, if they are not present, so then OH will be discharged. Okay, it will be discharged and O2 and water will be formed. So in this case, OH negative and SO4 2 negative is there. Can you tell me which one will go now?
Um, so for 2 minus.
But I told you that if this
Wait,
is present, then they will go. Otherwise, what will go? OH negative will
oh,
go.
okay.
Okay. If
Okay.
halide ions are present, then halide ions are preferred. But if OH is present and no halide ion is present, then OH will be discharged.
Okay.
Okay. So now OH will be discharged and the reaction can take place. Now you understood?
Yes.
Sure. So now
Yeah.
can you explain me this process?
Okay. From
Yeah.
the beginning.
Yeah, then we'll do at least 2 3 questions. I'll be able to explain you. Let's then, the more
Okay.
you do practice, it will be more clear to you. So we'll do practice. So okay, just explain me this. What has been happening in electrolysis of the aqueous solution?
Okay. So in the electrolyte, what for the positive, no, for the negative electrode, um, if the
You can explain me in terms of copper ions and hydrogen only. No
okay,
issues. Yeah, that's okay.
um, so if the copper, like, or whatever's in place of copper is more reactive than hydrogen, then it will go to the cathode. But if hydrogen is more reactive, then hydrogen will go to the cathode.
Excellent.
And then for the
The
positive
more
electrode,
reactive will stay at the solution.
yes, sorry, that's what I
Yes,
meant.
yeah, you're
Yeah.
saying opposite, no issues. But the if you see, the more reactive out of these two will stay at the solution, the other one will go to the negative electrode,
Cathode.
right?
Okay.
Yes.
Yes.
And the next one,
And then for the anode, if there is a halide present, then that will go to the anode. But if there isn't, then OH minus will go to
OH
the anode.
minus will be good. So is it clear to you?
Yes.
Yeah. So let's try doing some questions. I think we can try now. Okay. So now I'm going to show you a diagram. Let's discuss. Okay. So we have a diagram like this, and so here we put NaCl solution. NaCl solution. Here something is coming out, that is we call it as gas A. Here something is coming out, we call it as gas B. It's just for your practice, okay? So
Okay.
we call it as diaphragm. Basically it is keeping two things different. Okay, and this we have a solution C. This is a positive electrode and this is a negative electrode. Positive means cathode or anode?
Anode.
Positive.
Anode.
Excellent. Anode. Just to avoid confusion, that is why I am writing this thing for you.
Okay.
This is cathode. Okay. So now I'll repeat the question. See, this diagram shows the electrolysis of NaCl aqueous. Now you understood?
Yes.
So now you have to explain what is meant by electrolysis.
Okay.
So
Wait, so do I
basically,
just
yeah. So basically, you can explain.
the process?
Okay, when an electric current is passed through the electrolyte, right?
Yeah. Sorry.
Then what
Wait,
happens?
so do I like explain what's happening in the diagram?
Okay. So see, when the electric current is passed through the ionic substance like NaCl if you're talking, so what happens? The ions from the liquid or the solution, it moves towards the electrode where they react and they cause ionic substances to decompose. This is we call it as electrolysis. So you
Okay.
just have to define that. That means you are supposed to give a definition of electrolysis.
Okay.
Definition says that electrolysis is the electric current which is passed through the ionic substance. Then ions they move towards the electrode where they react and they cause these substances to decompose. We call it as electrolysis. Okay. So
Okay.
now you have to identify which one is gas A, which one is B, and what is C? We have NaCl aqueous. I am talking aqueous. That means you have Na positive, H positive, Cl negative, and
OH negative.
OH negative. Right? Let's try to solve this. So now, what happens at anode?
Um.
Loss of electrons. Right?
Yes.
And if the loss of electrons means oxidation.
Okay. So Cl.
Excellent. So now what is happening? We have these two ions. So that means the negative this will go towards here and the positive will go this side, right? Right?
Cl minus is
Yes.
a
So
halide.
now
So
excellent. So now what is happening when halide ions is present and OH is present? Which one will be which one will stay with the sorry, which one will go? Which one will be discharged?
Cl minus.
The halide ion, right?
Yes.
It will be discharged. I told you that. So excellent. So for gas A, can I say it is chlorine?
Yes.
Chlorine always, Cl2. You know that Cl2, it is a diatomic molecule, right? In periodic
Yeah.
table also you have covered in halogens. Is it
Yeah.
clear to you now? It's
Yes.
easy. Like you first split up. Here the in the question only they have written aqueous. You split up things and then you take up like this. Okay, in anode this will go. So now out of these two, what will be discharged? Cl will be discharged. So gas A, that means chlorine gas will be discharged. Now let's talk about B, gas B.
Sodium is more reactive than hydrogen, so sodium goes.
Sodium gas is there. Sodium
Oh.
gas is never there.
Oh.
Yeah, so what will be
Wait.
discharged? Hydrogen gas will be discharged, and I told you
Sodium
whatever.
stays.
I'll just tell you one more thing. Hydrogen gas will be discharged, okay, and sodium, since it is more reactive than hydrogen, so it will stay in the solution here, right? So then what is left? Na is left plus OH is left. So
OH.
yes, now you understood.
Yes.
You have to see this thing. So now in this case, in negative electrode, out of these, this is more reactive, so it is going to stay in the solution. Hydrogen will move up. You understood now?
Yes.
Yes. So in anode, what used to happen is if these two are present, who will be discharged? The halogen, the halogens or the halide ions, they will be discharged. So now if you see, Na and OH are left, and here you got an answer. Now is this okay to you? Clear?
Yes.
Yes. So you just have to see small things. I think this is the best way, if you could write the positive ions at one side, negative ions at one side, so that you can at least compare them. Okay, so let's talk about the next one. See, the sodium manufactured by the electrolysis of the molten NaCl. So now Na is passed at the negative electrode, okay, and chlorine it is passed as the it produced at the positive electrode. That's what we have got from here also. So now why does NaCl have to be molten before it will conduct electricity? This is a very general question. So
Um,
yeah, why does NaCl have to be molten before it will conduct electricity? You have given me the answer. It is just the way I have asked you. Can I repeat once more? Or I'll give you a
um,
hint. Why does
I don't
NaCl have to be molten before it will conduct electricity? So
because
in
wait,
yeah,
no.
tell me please.
No, it's fine. I don't.
See now, Sarah, you already know this answer. You've already explained me also. They have asked why does NaCl have to be molten? That means they are just asking you that they cannot take the solid NaCl. Why? Because those ions they are fixed position. They cannot move. Whereas when NaCl is in molten form, when it is in aqueous form, they can easily conduct electricity because in liquids the ions are mobile. They are free to move. You got it?
Yes.
This you have already told me that why solids they do not conduct electrolysis. Why? Because they are ions or they are the atoms they are at the fixed position. They cannot move. Whereas in liquids they can move freely so that they can conduct electricity. So it is the way how they have asked it.
Okay.
Okay, so
Yeah.
now let's try. Don't worry, it will come with a practice only. Okay, so no issues. At least you're trying and it's good. You're learning. We're trying to do lots of questions. It's very good if we are doing practice. Then only you will understand things. You know, it is the way how they have asked it. Otherwise, you have already given me the answer in the starting. So now let's see. We have one half equation, ionic equation. I'll give you. If you want me to repeat something, please tell me. I will do that. If you want me to explain you the reactions of electrolysis, that also I can do. No issues, but you tell me. This is sodium, and they have told this is electron, and sodium atom is formed. Now, can you write the half equation for the formation of chlorine? Can we do that?
Cl minus. Uh,
Excellent.
goes to.
Oh, how come here will be electron? So that means this is what this is reduction. So when what is electrolysis? At one side reduction is taking place, the other is oxidation taking place, right?
Yes.
Yes. So now if you see, can I explain you
Uh,
one thing? Otherwise, can I explain you what happens at the electrode? Those four steps which I told you.
yes.
Yeah, it will be somehow like this. Okay, this is the Ionic equation. Give me a second. I'll just take 5 minutes and I'll explain you the one more thing.
Okay.
I think you've forgotten. Okay, don't worry. So now I'll just give you a general equation. Now we have this. We have two electrode. Okay, here we have a solution. So now this electrode is attached to this. So this is the cathode and this is the anode. Okay, we have a electrolyte inside here. So that means electrolyte you can say I'll take a term metal and non-metal. That will be more clear to you. Or let's take an example. Wait, I'll give you an example. Let's take the example of PbBr2. Last time I explained you like that only. Okay, now you have here PbBr2. Understood?
Yes.
Yes. So now if you split this ions, that means Pb2 plus, and this is Br negative. Right?
Yes.
Yes. Is it clear to you till now?
Yes.
Okay. So now whenever you write ionic equations, the half ionic equations, so now how do you write it? See, now let's talk about first thing. Take one electrode, negative. Let's talk about negative electrode, that we call it as cathode. You
Wait, can
have
I
to
just ask a
always,
question?
yeah, there are four steps which you always have to follow. Then you will never go wrong. So first thing
Um,
is you have to write the symbol for the ion. So negative means, negative electrode means the Pb, the positive ion will go towards this thing, negative, right?
yes.
You understood?
Yes.
Yeah, because of the opposite charge, this will go this thing. So the first more thing is that you are going to write the charge, the ion. The ion is Pb2 positive, right? The second step says you have to write the symbol for the atom which is produced. So now if this is the ion, what will be produced? Pb
Um,
atom. This is the ion, this is the atom. First thing you have to write at negative electrode which atom will come, or which ion will come. So that you have already told that 2 plus will come.
okay.
No, what do you mean by
Mhm.
okay? Now, have you understood? See, this is positive. Okay, what is electrode? The cathode. Cathode is negatively charged, right? This you are aware. This part is negatively charged. So the positive ions will be attracted towards the negative ion. That is for sure. The positive ions will go towards negative electrode. Is it clear?
Yes.
Sure, you understood because it is opposite charge. What is there? Positive repel each other. Positive, negative attract each other. Opposite charges attract each other. So here we have negative. The electrons are there, and it is two positive. Positive will go towards this side. Correct?
Yeah.
First thing you have to write the ion. Second thing, when it goes towards here, so a atom is going to produce. So you write the symbol for the atom. Is it clear now?
Yes.
Yes, the third step says, see now from Pb2 positive, Pb2 positive, it is going to get converted to Pb, right? So then you have to balance number of atoms. So here number of atom is 1 here, and here also number of atom is 1. Atom, I'm not talking about the charges.
So,
Here one
yeah.
atom is there, na, right? So here is also one
Yeah.
atom. That's balanced. That's balanced.
Yes.
Yes. So now if you see, now the fourth step is you have to balance the charges. How do you balance charges? If I write like this, so that means, can I do balancing like this?
Yes.
Right? So these four steps, whether it is taking place at negative electrode or positive electrode, you have to remember these four steps. First you have to write the symbol for the ion, then symbol for the atom, then you have to calculate number of the atoms, balance them, then you have to balance the charges. So now is it clear to you?
Yes.
Now Sarah will be going to tell me what will happen at the positive electrode, that is anode.
Okay.
Okay, you go with the steps what I have taught you here.
Okay.
This way your ionic equation, the half equations will never go wrong. I'm telling you, this is the best way to uh, learn it. So now the first step was, this is
The
happening at
ion.
the a positive electrode, that is anode. So that means negative ion is going to, right?
Yeah.
Because it is
Wait,
negative.
so no,
First
it's
step,
B
yeah, tell me the symbol for ion.
Br minus.
Excellent. So the second step, you have to tell me which atom will be formed here.
Br.
Can I say Br2 because it is a diatomic molecule? If you know halogens, they exist as biatomic.
Yes.
Yes. The, you know that, right? In periodic table you
Yes.
have covered that. So third thing is, now now the third thing is, you have to measure the balance the number of atoms. So if you see, from Br negative, the reaction is being taking place to Br2. So how many atoms are there?
So you need to put a 2 in front of Br minus.
Excellent. Right. So now it is a balanced one. Now the fourth step is, you have to balance the charges. You have to balance the charges.
Um,
They have 2 electrons extra. So can I write like this?
yes.
They have 2 electrons extra. So if I write like this, it will be balanced.
Yes.
So now this, you understood the 4 steps. So now you can say, at negative electrode, the Pb is being formed. Okay, at positive electrode, the bromine is being formed. Now you know the balancing.
Yes.
Yes. So now in this case, when we were talking in the case of chlorine, so now sodium plus this thing, it will happen at the negative electrode, right? So at anode, what will happen? This will happen. I told you how to write the reactions.
Yeah. Wait.
Yes. First you decide out of these which one will be there. This one will there. If this is present, so this is going to get discharged. So that means chlorine will be formed. How chlorine will be formed? Through this reaction only. You will write first the symbol, and then what you are going to write, the
Atom.
atoms. Then you have to balance them, and then you have to balance the charges. So if you do like this, if you follow these steps, did you correct the correct answer?
Yes.
Yes. So that is why I am teaching you this way, so that you get the correct answer. So then you
Okay.
get to know only that, okay, chlorine is being discharged. Clear?
Yeah.
Yes. So let's do some 2 more questions. I hope this is clear to you. The steps are clear to you.
Yes, it is.
Okay. So now if we talk about we have a table. Okay, I'll give you a table, and it shows the results of the electrolysis of the aqueous solution. So you have to read it very nicely. Okay, using electrodes, the solutions were electrolyzed under same condition. All these solutions, they are electrolyzed under the same condition, and they all are aqueous solution. So now I am going to tell you solution. Now you have to tell me the product. I hope you have a paper or pencil. You have?
Yes.
Yes. Now you have this thing. So remember one thing I am saying again, it is a aqueous solution. So you understood? Water is there. Product at positive electrode, product at negative electrode, and substances left in the solution at end of electrolysis. Okay, so the first one I'm going to give you is, let's talk about the easy one, copper sulfate. So now if you talk about the electrodes at negative, the product at the negative electrode. Negative electrode is
Um, copper.
negative electrode. Negative electrode is cathode, right? Cathode.
Yes.
Okay, and when copper is excellent, so hydrogen, because it is been more reactive, will stay in the electrolyte, and copper will be excellent. Now what will go towards positive electrode? Sulfate ion is present, and what else? OH negative ions is present.
Um, but sulfate ion.
Why sulfate ion? I told you when OH,
No, well,
yeah, when OH negative ion is present, and when the halide ion
no, I
is
mean,
present, then halide ion goes, otherwise always OH will go,
okay.
right?
So that,
Yeah, so I told you when OH will go, what is it going to form? It is going to form O2. When OH, I told you when OH, out of these, when they are present or halide ions present, then which one goes? Halide ions are preferred, right? Right?
yeah,
When OH ions are present and any other are present, non-metals, then what happens? The OH is discharged into oxygen, and plus water is being formed. You understood?
yeah,
Yes, so O2 will go. O2 will be at the positive electrode. Is it clear to you? Whenever is OH released, O2 and H2 will be formed. Clear?
yes.
So now what has been left at the end of the electrolyte? You have to tell me.
Um, uh, hydrogen sulfate.
Excellent. H2SO4. Correct. See, when you do practice, then your concepts will be very clear to you. So the next thing, let's take the example of K2SO4.
So potassium will go to the cathode.
Okay, because potassium is more reactive than hydrogen, so
Hydrogen.
potassium will stay in the electrolyte and hydrogen will go. Now,
Oh,
the
oh
more
yeah, okay.
reactive, yeah, the
Yeah.
more reactive will stay in the solution. So now at negative electron, what is going to form? See, this has been asked to you, like they'll give a chart to you and they'll give you 5, 6 out of these, and then the rest they'll just mark it as a blank and you have to fill it. So that is why I'm doing practice with you, so that it should be clear to you. So now
So
what is left? Yeah, O2 again,
oxygen.
right?
Yes.
O2. You don't have to write OH negative ions. OH negative ions I'm explaining you, but when it goes to the electrode, it always forms atoms. You understood?
Yes.
It always forms atoms. The atoms are formed. So that is why I'm writing O2. So now what is the substance which is left in the solution?
Um, potassium sulfate.
Excellent. So now if we say mm, I'll say silver sulfate.
Silver is less reactive, so silver goes to the cathode.
Excellent. And out of the here,
And then O2.
right. I think now you know how O2 is going. And now what will be left?
Hydrogen sulfate.
See, it's so clear to you now. So it will come with a practice only. So it will come with a practice only. Okay.
Yeah.
Now it's clear to you, right? It's easy.
Yes.
Yeah, you just have to keep in some things in your mind. So now, okay, so one more we can do is like, okay, I have, you can say AgNO3, I'll give you. Now AgNO3. AgNO3. Can you tell me?
Um, so silver goes to the cathode,
Right.
and oxygen goes to the
Excellent.
the anode, and then so it's hydrogen
Nitric acid.
nitrate,
Nitric acid is
nitric acid.
HNO3, right? So it will be like HNO3, right?
Yes.
Yes. So now let's do one more thing. Now it's easy for you. I hope it's clear to you also.
Yes.
Yes. So let's do. Now I'll ask you. See, water. I'll give you diagram first. So we have kind of a two test tubes, and there are two electrodes here. Okay. This you say it as negative. This let's say it as positive. And here we have H2 gas, here we have O2 gas. You can see from the bubbles, okay, there are bubbles. So now water can be decomposed by using this apparatus. Okay, you're decomposing the water. Decomposing the water means, what do you mean by decomposing a water? You're
Um,
breaking the water molecule, right? Now
yes.
that means water is being broken to H2 and O2, right? So
Yes.
if you balance it like some 2 to 4, so right. So the
Yes.
first question is, suggest a suitable element for inert electrode. Suggest a suitable element for the inert electrode. What are electrodes made up of? I told you.
Um,
It can be
and
carbon, graphite, platinum, copper, silver. Remember I told you in the starting
yes.
also? So that is
Yes.
what they are asking. So it is the way they ask. You understood now?
Yes. So is the
Yes.
answer just like copper or
Yeah.
silver?
Okay,
Okay.
excellent. Anything you give the answer out of these, you'll get marks. The second question I'll ask you, okay, suggest why small amount of dilute acid is added to water before it is electrolyzed. Why
Um,
is why we add small amount of dilute acid?
um,
Why we add it? Because if you see, we are supposed to decompose. Okay, this is decomposition, but when you add, I told you in the starting, uh, I think it is, I think in the slide third, I'll just see. Okay, I think I rubbed it. So now the thing is, whenever you add acid to water, so I what have I told you, it will start giving the ions, right? H
yeah.
positive, OH negative ion. This is, and we want ions only here. So a small amount of dilute acid is added to water before it is electrolyzed, so as to increase its conductivity, so that it can split up into the ions. You understood now?
Yes.
Yes. So it is that only. So now see, this you already know, but the way they ask you is totally different.
Okay.
Now it's clear to you.
Yeah. Wait, could
Yes.
you explain it one more time?
Yeah,
Sorry.
yeah, that's okay. I'll explain. See, if whenever you add, I'm talking about right now is decomposition of water. Okay, but this is the reaction, okay, decomposition. But can you see anywhere ions?
No.
No. So when you add dilute acid to the water, okay, before electrolysis, so what happens? These ions are formed. And if you see, whenever you carry out electrolysis, what do you require? You require ions, right? then ions get converted to the atoms. You understood?
Yes.
So now we can say that we add dilute acid to the water because so as to increase the conductivity. What is increase the conductivity means? That basically to increase the electrical conductivity so that the electric current can be passed to it.
Okay.
Now it's clear?
Yes, I understand.
Yes. So now the next I'll ask you one more. See the volume of the oxygen, if you see, they are saying the volume of oxygen collected is slightly less than expected, though there are no leaks in the apparatus. Can you tell me the reason for this?
Um, Wait, sorry, what was the question?
Okay. See, they are saying the volume of oxygen which is collected here, okay, that is
Yeah.
slightly less than expected. And there
Mm,
are no leaks in the apparatus also. So then where is the rest of the oxygen going? So can you give me the reason for that?
um,
Okay, what happens at positive electrode? Can you tell me what happens at positive
oh,
electrode?
oxidation.
Okay, oxidation, but we have OH negative ions. I told you when they are present, so what happens? The oxygen is being discharged and water is being formed, right?
Yes.
Yes. So now the oxygen is being discharged and water is being formed. So now if you see there we have oxygen. So that means some of the oxygen it goes into the water. Can I say that?
Yes.
So now this is what happening. So that is why the concentration of oxygen it comes out to be less. Is it
Okay.
clear to you now?
Yes.
I explained you that at positive electrode OH negative ions are formed. So now what happens is OH is discharged and water is being formed. So that means water, if you see, it contains O. So now some of the oxygen is being going to the water. Is it clear to you?
Yes.
Yes. So the basic concept you can easily do it. If I give you any of the ionic solution, you will be easily be able to do through those 4 steps. Okay. But this is also very easy. It is the way they have asked it.
Okay.
Okay. So now this will come with the practice only. So anything you want to ask me till now? Are you clear of everything?
Yes.
Sure.
Yeah.
You can at least see. You have covered so many questions. I'll show you. Like six. See, you have covered so many. One, two, three, four. You can easily do the electrolysis of these, right? At negative electrode, at positive electrode, and this thing. And plus you should know the electrodes are made up of which thing. Okay. Now you are clear about the formation of oxygen also, that OH will form oxygen and water, and some of the oxygen it goes to the water, so that is why the quantity of that is less, right?
Yes.
So anything you want to ask me right now about the electrolysis portion?
No, it's fine.
Sure.
Yeah.
Okay. So you just go through your textbook once. Okay, if you have any doubts, you ask me. But more of the examples are like these only. I've seen them.
Okay.
Okay, so try out. You'll be able to do it.
Okay.
Okay. So now, if